The topic of this lesson is regression equations. Example 1. John does not have a very good credit rating. In January of 2016, he found a lending institution that was willing to loan him $100,000 for 15 years at a higher than normal interest rate of 7.5% because of his poor credit rating. Examine the table of decreasing loan balances over the 15-year period. Use regression to determine a curve of best fit for this data. The best way to do this is going to be using a spreadsheet software, for example, Excel or Google Sheets. In this case, we're going to model this using Excel. I'm going to begin by highlighting both columns of data. I'm then going to go to Insert, Charts, and I'm going to select the scatter plot. I'm going to choose the first option right here. You'll notice that this shows us how the loan balance decreases over time. And you'll also notice that it forms sort of a curve, almost a line, but not quite a line. All right, so now what we're going to do is we're going to right-click any data point, and we're going to click where it says Add Trend Line. We're going to start with linear because that's the simplest. We're going to ask it to display the equation on the line. Now you are going to notice when the equation first displays, it displays in what looks like almost like scientific notation. And really Excel does that really just because it tries to minimize the amount of space it takes up. So what we're going to do is we're going to click here on Label Options while selected on the equation. We're going to change it from General and we're going to change it to Number. And you're going to notice that it expands it so we can see the actual equation. I'm also going to have it display for us our R-squared value. So when I click on this graph here again, this line, and I click display R-squared value, we see that it's R-squared is equal to 0.98. Now the reason I want to show that, if you remember before from the beginning of the year, the R values are our correlation coefficient. It tells us how closely this particular line fits this data. And the closer that value is to a 1 or a -1, the better the data fits it, right? Now 0.98 is a really strong correlation, so this is quite a good fit. I'm going to label this one here linear. So this is our linear regression. Now what I want to do is I want to determine if this is in fact the best regression model, or if there is maybe possibly a better one. So I'm going to repeat this process. So I'm going to select the data again, and I am going to insert our scatter plot. But this time, when I select, I am going to be selecting a different type of model. Okay, so I'm going to right-click the data, add trend line, but I'm going to select polynomial instead of linear. And I'm going to choose a polynomial of order 2, also known as a quadratic. Okay, I'm going to have it display the equation. Once again, I'm going to tell it, let's see if I can get it visible over here for me. You'll notice it comes out in that weird scientific notation. I'm going to click on the equation, change it from general to number so it expands. And then once again, have it display that R-squared value as well, right? So if we click on this again on my model and tell it to display our R-squared value. Now you will notice that this one comes out quite a bit closer to 1. Actually here you'll see that it shows that it's exactly 1. I'm not sure that it comes out exactly 1. It really depends on the rounding. So let's maybe round it out a little bit farther and see if that changes it. Now it still seems like it's really quite close to 1. So at this point we could already see that our quadratic model is definitely a closer match to the data, and we can see it visually as well, right? The majority of the points seem to nicely fit this curve, versus here some of the points are off the line and some are on it. Okay, now we're going to repeat the process and we're going to do it with a cubic. So I'm going to select both columns, insert, scatter plot again, and I'm going to repeat the exact same process. However, this time, when I add my trend line, I'm going to choose a polynomial of order 3, right? Or in other words, a cubic. I'll display the equation, and just like before, I'm going to change it from general to number so it expands. You'll notice it's quite a large equation. which is why Excel, tends to condense it into that scientific notation. I'll display the R squared value, and I'm just going to move this around a little bit so I can see it fully. Now, you will notice, I'm going to label each of these as well. This one was our quadratic regression. Let me zoom out a little bit so we can see everything. Quadratic regression, and this one we just did is our cubic regression. Just going to decrease the font size on that so it's not going on top of our equation. And then this one is our cubic. Now, you will notice that both the cubic and the quadratic regression equations quite nicely match the data, right? And they both have R squared values of about 1, right? So we could argue that both the quadratic and cubic regression equations are equally good fits for this particular data set. Meaning if I were to take this equation, right, and plug in a value for a year, for X, on either of these, I should get pretty close to the actual end of year loan balance. Now, I want to show you an example of what I mean. So if we take a look at our linear regression equation, for example, we will notice that we have here negative 6,777.54 X plus this 13,766,742.3. Now, this equation should be able to determine a value along this table, right? So I'm going to just do a little calculation down here. So I'm going to put equals our negative 6,777.54 times, and let's try for the year 2021, and let's see how closely this actually works, plus our 13,766,742.13, and let's have it calculate. So when we inputted that 2021, it came out about 69,000. Let's look here, 2021, and that's about 72,000. So it's off about 3,000, but it is relatively close. And so that was with our linear model. Okay, now let's try the same sort of thing, but with our quadratic model. Let's try 2021 as well. So this model is a little different. So this model is equals negative 251.095 times 2021, because that's our year, plus 1,900,153.328 times our 2021 minus, and that looks like, so minus 1,013,842,642.653. And we're going to see if I've typed that incorrectly because I may have missed something. So negative, I forgot the squared. So to the second power right there. All right, so this one comes out 73,520, and you'll notice here that that is a bit closer, right? It's only about 1,000 away from the actual. So we're going to put quadratic here, right? Now let's try our cubic. Now, in attempting to do the cubic, we're going to notice that the numbers are really quite unfriendly. So you might ask, how do mathematicians deal with things like this? So what we do, instead of referring to the years as these thousands, we're going to change all of our years to smaller numbers. So we will refer to year 2016 as year 1, and 2017 as year 2, and 2018 as year 3, and so on. And what you're going to notice as we make these changes, other than the crazy stuff that's appearing on the other side, you're going to notice that our equations are going to be a bit simpler than what they were before. But you're also going to want to notice that now, if I'm testing the cubic equation, I'm no longer going to be plugging in 2021. I'm going to plug in 6 instead. Okay, so let's go ahead and let's test our simpler version of our cubic equation. All right, so let's start with equals. We have negative 6.23. All right, so we're going to multiply by what 2021 corresponds with, which in this time is year 6, so times 6 to the third power because it's cubed, minus 101.67, okay, times year 6 to the second power, minus 3,747.48 times year 6, plus 100,142.23. And you'll see here we get 72,651. And if we look over here at 2021 or year 6, we'll notice that that is very close. It's actually so far the closest one. So we are going to say then that our winner, or our regression equation of best fit, is in fact our cubic equation. So we'll label this here as our best fit. It's our winner. And that's it.